20 years ago, scientists awaited the birth of an animal that was the first of its kind. Dolly the sheep was born in Edinburgh, Scotland. She was the first mammal cloned from an adult cell. Dolly lived until nearly 7 years old, not too bad for a sheep. 2 years before her death, though, she developed osteoarthritis, and when researchers examined her chromosomes, they found that she had shortened telomeres, a possible sign that her DNA was older than her actual biological age. This week, another team of scientists published a study that looked at the health of Dolly's sister clones, 4 sheep that were created from the same cell line. My next guest is here to tell us how that checkup went. Kevin Sinclair is an author on that paper. He's also professor of developmental biology at the University of Nottingham in Nottingham, England. Welcome to Science Friday.
Hi, John. Good to be here.
So, first of all, these sheep were created from the same cell line. You've called them sister clones. Are they exact replicas of Dolly?
So they're what we would call genomic copies, John. They share the same nuclear DNA. They're the same cell line, the same batch of cells, in fact, that gave rise to Dolly. But of course, the eggs in which the nuclei from these cells are injected are from different donors, from different animals, and so they share the same nuclear DNA, but they don't share the same mitochondrial DNA. So that's true for all clones generated by somatic cell nuclear transfer, and that's why we refer to them as being genomic copies rather than as purely identical.
So these 4 cloned sheep are now 9 years old. Sheep usually live 10, 12 years old or so?
Yeah, it's possible. It's kind of like humans. It's difficult to do a direct age comparison, but as a rough rule of thumb, you could say 1 sheep year is equal to 8 human years. And of course, humans are capable of living into their 70s and 80s and beyond, but few actually do that. These animals are probably now at 9 years of old, they're probably around about the 70-year mark.
And so how's their physical health?
The physical health is very good, as you probably could see from the pictures that have been circulated and also the video. They're out every summer. They're out in a paddock, and they will bring them in during the barn. One of the clones, her name is Debbie. When we undertook MRI and X-rays last year, she showed the most radiographic evidence of the most advanced osteoarthritis, but she was showing no clinical signs last year. But in June this year, just a month or so ago, we started to notice that she was getting a little stiff in the morning. So we've since been giving her a little medication from day to, not every day, but occasionally through her diet.
So overall, their health is better than Dolly's health was. I mean, Dolly, of course, didn't make it to 9 years old.
As far as we can ascertain, that's probably true. I mean, Dolly. The only thing that we could say about Dolly was that she developed osteoarthritis at a younger age than these animals, and started to show clinical signs at a younger age than these animals. I mean, Dolly died, unfortunately, because she just picked up a virus that causes lung tumors. It's prevalent throughout the world, and its prevalence in the UK is quite low. And so she and other members of the flock were really unlucky to have picked up that virus, and that was the reason for her early demise.
I'm John Dankosky, and this is Science Friday from PRI Public Radio International. We're talking with Kevin Sinclair, who's a professor of developmental biology at the University of Nottingham in Nottingham, England, about sister clones of Dolly the sheep. So Dolly was a success, but it took about 300 attempts or so to get there. How has cloning technology changed over the course of the last 20 years?
So it's moved a long way, in fact. Modern protocols now for cloning animals are much more efficient than they were at the time that Dolly was created. And there's the level of research isn't as great as it once was, because if you were to think about what was cloning's greatest legacy, it probably was, it demonstrated for the first time that you could induce what we call pluripotency in cells. You could take a terminally differentiated cell and restore it to something akin to an embryonic cell, which is capable of dividing into many cell types. And that was the impetus for scientists to look at ways of trying to do that in the laboratory, and that led to the discovery that you could induce cells to become pluripotent by using a small number of genes, and so-called induced pluripotent cells, stem cells, is really what's taken off since. So cloning is still undertaken, particularly in the United States. And the protocols being used today are much more efficient and much more effective. So we can be hopeful with the research that's taking place that in the future we could maybe see more healthy cloned animals like this.
So what do these healthy cloned animals tell us about what cloning might do for us? I mean, we've been thinking about cloning and its use in human medicine for years. Do the next 20 years bring something in which cloning actually helps us live longer, be healthier?
So, as I said, the field has kind of moved a little bit away from cloning in some respects towards these iPS cells, and I think that's where most of the activity is likely to be in future. There are 2-3 labs that are cloning human embryos with a view of generating human embryonic stem cells for therapeutic purposes, and it's evident that that process is actually really quite effective in inducing pluripotency. What this particular study shows us, however, is that there's a population of cells that quite clearly undergo, for all intents and purposes, almost complete reprogramming to produce normal embryos which give rise to normal pregnancies, and then normal offspring which can live a long time. And so where there are some cells that can undergo effectively complete reprogramming, and that gives us hope that in the future, as we refine our techniques, that we can expect a much larger population of these cells, and so that we can use either cloning or iPS cell technology with more confidence that we'll produce cells which are effective and also safe for use.
I just have one last quick question for you. Are there more Dollys coming from this line of sheep?
No, it's not likely that there will be. I mean, this is an opportunity. My former colleague Keith Campbell, who passed away in 2012, he was interested in evaluating his protocols to go back to the original line and to see how far things had progressed. It's likely in the future that we're going to move forward with the other cell lines.
Kevin Sinclair is a professor of developmental biology at the University of Nottingham in Nottingham, England. Thank you so much for joining us, sir.
Welcome.